In this video, I'm going to show you how to solve an inequality. And first, we'll go over the regular situation, and then we'll talk about the compound inequalities. So this is the first one. We have 17 minus 2 times the parentheses with x plus 3 inside, and this is less than or equal to negative 4 plus x. Solving an inequality, it's almost the same as solving an equation. There's only one thing that's different. And also, you'll see that we have this symbol. We will be using the inequality symbol to identify what's the left-hand side and what's the right-hand side. And first of all, we see that we do have this parentheses, so as usual, we have to take care of that parentheses. That means we look at the number, in this case, it's the negative 2. We distribute, right? Therefore, we have 17, negative 2 times x, we will have negative 2x, and then negative 2 times positive 3. That will give us negative 6. And this part stays the same because we didn't do anything with it, less than or equal to negative 4 plus x. So take care of the parentheses first. And then focus on the left-hand side, combine like terms as much as we can. In this case, we have the 17 minus the 6. We can combine them together. 17 minus 6, that's 11. And then this is minus 2x. And we bring this down, less than or equal to, and this stays the same again, negative 4 plus x. And now we see we have x on both sides, and then we have numbers on both sides, right? To be consistent, we are going to make sure bring all the x from the right-hand side to the left-hand side, and then bring the number from the left-hand side to the right-hand side, just to be consistent. And I make a video on why we should have x on the left-hand side, so you can check that in the description or somewhere on the screen. I'll put that up right here as well. With that being said, remember, we want to bring all the x from the right-hand side to the left, right? So I want to get rid of the plus x. What should we do? Well, we just need to subtract x, and this way, this and that will be cancelled. And we do the same right here, minus x. I want to get rid of the 11, so I can bring the number to the right-hand side. So I have to minus 11, so that this and that will be cancelled. And I'll also subtract 11 right here as well. And let's see what we have right here. And be sure you see, all we are doing right here are just subtractions accordingly, right, with the number and the x like this. We do not need to switch the inequality symbol. Let's work this out right here first. Negative 2x minus x, that will give us negative 3x, and this stays the same, less than or equal to negative 4 minus 11, that's negative 15. So far, so good. So far, it's just the same as solving equations. Now, we have negative 3 times x. What should we do to get rid of the negative 3? The answer to that is, we are going to divide by this number, which is negative 3. Likewise, we divide this by negative 3 as well. This way, this and that will be cancelled, right? So now let's work this out. This is just going to be x by itself. And when we work this out, negative 15 divided by negative 3, we get what? Positive 5. All right, here comes the part that we have to remember, and that's the only thing that's different than solving a regular equation. Whenever we multiply or divide a negative number, just like this right here, we must make sure, look at the inequality symbol and switch it. This is less than or equal to, so we switch it and we will end up with a greater than or equal to. Once again, whenever we multiply or divide by a negative number on both sides of an inequality, be sure we switch. Negative numbers, okay? Divide or multiply. This right here is it. X is greater than or equal to 5. And right here, this is how you answer it with an inequality. And of course, we are going to talk about how to make a graph of this inequality. Well, to do so, you're just going to draw a number line and then indicate, here's my 5. And then this is greater than or equal to, so we are going to use a closed circle. This will indicate that we want to include the number 5. Do we go left or do we go right? Greater than. X is greater than. Therefore, we go to the right, like this. Okay, I'm just going to color this and then draw an arrow. 5 or bigger. X has to be at least 5. And this right here is the graph. Another thing that we have to do is the interval notation. So also let me write this down right here for you guys. For the interval notation, we only have one piece right here. To do that, we first write down the left number. In our case, it's 5. And then, because this is keep going to the right, that will be positive infinity. So 5, comma, infinity. For the 5 right here, we are including it. Therefore, we're going to use a square bracket like this. And then for infinity or negative infinity, because we cannot include what infinity is, we will always use a regular parentheses for infinity. And that's it for the first one. And before I show you guys the next one, which is going to be a compound inequality, I'm going to explain to you guys why that when we multiply or divide a negative number on both sides, we have to switch the inequality symbol. So to explain why, let's first look at two numbers. And let's say we have the numbers 18 and 24. Which of this is bigger? We all know it's 24. And we are going to put on this symbol, isn't it? So we know 18 is less than 24. And let me suggest you guys always read this from left to right, even though it's not wrong to say 24 is bigger than 18. But seriously, be consistent. 18 is less than 24. Read this from left to right. And now I'm just going to divide both sides by a negative number. Let's say I'm going to divide both sides by -3. And now let's work this out. 18 divided by -3, we get what? This is going to give us -6. And here we have 24 divided by -3. We end up with -8. And now, let me ask you, which number is actually bigger now? The answer to this is -6. It's actually bigger. -6 is bigger than -8. So you see, whenever we divide both sides by negative number, same thing with multiplying by a negative number, we must switch the inequality symbol. And the reason is because the more negative you are, in fact, it's smaller, right? This is more negative than -6. Therefore, it's actually smaller. And now let's work out this compound inequality. And we know this is a compound inequality because we have 1, 2. Two inequality symbols, right? And the best way to read this is that we're going to say this as x plus 5 over 2. This is in between of -4 and +7, not including -4, but we are including +7. We use the word in between whenever we have this kind of situation. And you see, this is the first kind of compound inequality, the AND situation, because this is in between of -4 and +7, not including -4, but including +7. We also have another situation, the OR situation, but we'll work that out later. And let's see, we have x plus 5 over 2. The x is in the middle. We have to get the x by itself, right? What can we do to get rid of the over 2? This is like dividing by 2. So we have to multiply by 2. This way, the 2 and 2 will cancel. And you see, right here we technically have 1, 2, 3. 3 sides. I did multiply by 2 right here in the middle. I just have to now multiply the left right here by 2. And also do this 2 right here. The right hand side right here, multiply by 2. Multiply by 2 to all 3 sides. Whatever you do now, you do that to all 3 sides. And we will have -4 times 2, that's -8. And this is less than, and you see, that's just a +2. We didn't have to switch the inequality symbol. Here we have x plus 5, and this is still the same, less than or equal to 7 times 2 is 14. And next, what do we do? We have x plus 5. We have to subtract 5. Subtract 5. Subtract 5. This way, this and that will cancel, right? Okay, and you see, we are subtracting 5. -8 minus 5, that's -13. We maintain the same symbol. We don't switch. Only multiply or divide by a negative number. This right here, we didn't need to do that. x will be in the middle, and it is by itself now. And then this is less than or equal to 14 minus 5. That's positive 9. And we are done. This is the inequality way, okay, to show the answer. And now let's look at the graph. For the graph, in this case, as you can see, this is how we read it out loud. X is in between of negative 13 and positive 9 for the answer. Not including negative 13, but including positive 9. And for the graph, put on this and that. Let's say this is negative 13, and this right here is positive 9. 9 including negative 13, so open circle. Including positive 9, so close circle. X is in between, therefore you color in the middle. Okay, make this stand out, darken it, make it stand out. This is the graph, the middle section. So you know the lower bound and the upper bound number, right? The smaller number and the bigger number. At the end, we have the interval notation. And we only have this interval, and we have two ends. First, put down the smaller number, which is negative 13, and then comma. Here we have the positive 9 for the bigger end, right? Open circle, we use regular parentheses. Closed circle, we use a square bracket. This is it. And now let's look at worst situation. This one is 9x is greater than 5 times the parentheses with 3 plus 2x inside. Or the second one is 3x is greater than negative 4 minus 9x. And the way to solve the or situation, compound inequality, is to just do this one first and then do that one. At the end, we put the answers together. So let's focus on this one first. We do have this parentheses with the 5 inside, right? Therefore, we'll take this 5 and distribute it into the parentheses. And we will have 9x is greater than 5 times 3 is 15. 5 times positive 2x, that will give us plus 10x. And for the next step, as we can see, we have x on both sides. Well, let's be consistent. Let's move the x to the left-hand side. We should have the x on the left-hand side at the end anyways, right? So let's subtract 10x so that that will be cancelled. And we'll do that to the left-hand side also. And I know we will end up with a negative x in this case. 9x over 9x minus 10x gives us negative x. But we can handle negative numbers. We can also handle negative x, right? So this gives us negative x, and this is greater than 15. And you see, we just subtract earlier, so we maintain the greater than symbol. And now what? This is negative 1 times x is greater than 15. So to get rid of the negative 1, we are going to divide both sides by negative 1. Negative 1 cancel, and we get the x by itself, and it's positive x. Do the same thing on the right hand side. Here we have x, and then this is 15 over negative 1. We will end up with negative 15. But then we did divide both sides by a negative number. So this was a greater than originally, right? We'll have to change that to a less than. X is less than negative 15 for the first one. And now let's move to the second one here. 3x is greater than negative 4 minus 9x. Once again, let's move the x to the left-hand side. This is negative 9x, so we have to add the 9x on both sides. They will cancel, right? So let's do that real quick. And then we have 3x plus 9x, that's 12x. Maintain the same symbol, the greater than, and this is negative 4. And now what? This is 12 times x is greater than negative 4. What do we need to do to get rid of the 12? We have to divide. We have to divide both sides by 12 so that they will cancel. Likewise, divide this by 12 as well. And it was a positive 12. We divided both sides by a positive 12. We get the x isolated, but the 12 was positive. We maintain this to be greater than. We don't need to switch the inequality symbol. And then we work this out. Negative 4 over 12, we get negative 1/3. Even though this value here is negative, but you have to remember it's the procedure right here. When you divide a number on both sides, if this is a positive number, we don't need to switch the inequality symbol. And we are done. This or that. And that's how you answer it with inequality. And you pretty much have to box both of the answer on the test, right? This part or that part. And we will also use the graph, okay? So to do the graph, I'm just going to draw a number line. Two numbers to be considered, which is negative 15 and negative 1/3. In fact, negative 1/3 is bigger than negative 15, so we'll put it down like this. Well, this is just a less than, so open circle, and for the negative 1/3, it's also just a greater than, so open circle. X is less than negative 15, so we move to the left, right? So shade it to the left. For this one, it's greater than, X is greater than, so we go from here and then we go toward the right. Just like that. And now also for the graph. At the end, we have the interval notation. And be sure you need to know all these three ways to present your answer and just follow the direction on the test. Sometimes the question will ask you to graph it, sometimes write the answer in the interval notation. Okay, we have two pieces. Let's write the interval notation for this one first. As you can see, we have the arrow going all the way to the left, right? In that case, the starting value, it will be negative infinity because it's going all the way to the left. And then the ending value on the right for this piece is negative 15. All right, for infinity or negative infinity, always parentheses. This is the open circle for the negative 15, so open parentheses also. We do have another piece. In this case, we are going to use a union symbol, meaning we are going to put this together. For this piece, we begin with negative 1/3, and this is going all the way to the right. That means we have positive infinity. Negative 1/3 is an open circle, so parentheses, likewise infinity, we cannot include infinity, so open parentheses. This right here is it, and hopefully this video helps. And if you have any questions, you guys can leave the comment down below. See you guys soon. Okay.
That's it.